Today's topic is the derivation for energy band structure of open circuited PN junction diode. So this is the energy band diagram. This side is the P region and right hand side is the N region. In between we have the space charge or accumulation region. So the center line is the Fermi level line, and we know in the P side the level shifts towards the top and N side it shifts towards the bottom. So this gap, this total gap is Eg. So this again is half A. This is totally Eg, forbidden energy gap. So this would be half Eg and the other half would be half Eg. The same for the other side as well. This dotted line, no, this dotted line is the exact center of the forbidden energy gap. So from the dotted line to the ECP is half Eg, dotted line to the bottom EVP is half Eg. Same way here, dotted line to ECN is half Eg and dotted line to EVN is half Eg. So here ECP is the conduction band for P side, EVP valence band for P side, ECN conduction band for N side, and EVN valence band for N side. The bottom we have valence band and the top we have the conduction band. So this distance is E naught between actually the ECN and EVP. The distance between ECN and EVP is E naught. Also, this distance is E naught from EVP to EVN. Also, ECP to ECN distance is also E naught. So this distance E1 would be equal to this whole distance half Eg minus this distance. Same way here, this distance E2 will be equal to E naught minus this half the distance. So we would start with the derivation. So EF should be constant throughout the specimen Fermi level at equilibrium. EF for the two sides there. So it is, we start with the derivation. So E naught equal to E1 plus E2. We have the diagram here. E naught equal to E1 plus E2. And then equal to ECP minus ECN equal to EVP minus EVN in the valence band side. This energy E naught is the potential energy of the electrons at PN junction and is equal to QV naught. E naught equal to QV naught. And contact difference of potential EF minus EVP equal to half Eg minus E1. EF minus EVP. So EF minus EVP is this distance is equal to half Eg, this total distance, minus this E1. So this distance is equal to half Eg minus E1. Same way on the other side, ECN minus EF equal to half Eg minus E2. ECN minus EF is equal to half Eg minus this distance E2. So combining the equations, E naught equal to E1 plus E2 we have the values for so it is equal to Eg minus E1 value we have, E2 value we have, and E1 plus E2 equal to, so Eg, half Eg plus Eg is half Eg is Eg, plus EF minus EVP plus minus ECN minus EF. So E naught minus E naught equal to this value. So to find this we need the values for Eg, EF minus EVP and ECN minus EF. So NP equal to NCNV e power minus Eg by KT, and we also know by mass action law NP equal to Ni square. So from this equation Eg equal to KT ln Nc, from this equation E naught equal to KT ln Nc Nv by Ni square, and for N type material EF is Ec minus KT by KT ln Nc by Nd. So ECF minus EF equal to KT ln Nc by Nn equal to KT ln Nc by Nd. Similarly for P type we have EF equal to EV plus KT ln Nv by Na, and EF minus EVP is KT ln Nv by Pp. So we have equation for ECN, EF, EF minus EVP and EF also. So substituting all that equation in E naught equation, we get E naught equal to KT ln Na Nd by Ni square. And we know E equal to QV naught. So substituting that here in place of E, QV naught equal to, so V naught equal to KT by Q ln Na Nd by Ni square. So considering Nn equal to Nd, the number of donor atoms, Nn Pn equal to Ni square, and Pn equal to Ni square by Nd, Pp equal to Na, then Np equal to Ni square by Na. So E naught equal to Kt Ln by Pp naught by Pn naught equal to Kt Ln Nn naught by Np naught. So this is regarding the derivation for energy band. Thank you.